10 to the minus 1 is 1 over 10.
Yes.
Which we write as the decimal 0.1.
Yep.
Okay. 1 over 10 to the minus 2 is 1 over
100.
100, which we write as 0.01. So we're going to do roughly the same thing with our 4s. So 4 to the 0 is 1.
Yeah.
4 to the 1 is 4.
Yeah.
4 squared is 16. Yep.
Yeah.
Now, when we go this way, 4 to the minus 1 is, what's that going to be, 1 over 4.
Yeah.
Which we would write as a decimal as
which is not 0.4. I was close. But
yeah.
Yeah.
No, it's 0.25.
Yeah.
So 0.25. The next one down is 4 to the minus 2. Well,
1 over 40?
No, remember it's actually 1 over 4 squared. Remember how we have this idea that...
Oh, it's the flip, it's the reverse.
It's the reverse, yes.
Yeah.
So negative in there says, let's take the reciprocal 1 over, 4 squared. So we get rid of the negative just there.
Yeah.
So
1 over 16. Okay.
It's 1 over 16, yes.
Ah.
So you see the thing here, we've got 4 to the 1 is 4, but 4 to the minus 1 is 1 over 4.
Yeah.
4 squared is 16, so 4 to the minus 2 is 1 over 16.
Yeah.
Now, if we had 4 cubed, that's 64.
Yeah.
4 to the minus 3 is 1 over
4 to the 3. Yeah.
Yep. Which is 1 over 64.
Yeah.
Okay. Which is really what's going on here, only it's kind of hidden because we've got these easy decimals. I mean, these are not so easy to write out, the powers of 4. So, going back to, what was the question? It was log base 4, 1 over 4. Well, you sort of look down here and you say, well, which of these numbers do I want? Oh, it's that one.
Yeah, the negative 1.
Power, so it's going to be negative 1.
Yeah.
If you ask what's log base 4 of 1 over 64, you look up and down here and say, 4 to what power gives you 1 over 64? Well, it's minus 3.
Yeah. In an exam, if we sort of did that sort of working out, like wrote 4 to the 3 equals 64, 4 to 2, blah, 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 would that be all right to sort of show the examiner that that's sort of your trail of thought? Or
yes, I mean, that's one way of doing it. I mean, I think a slightly more succinct. Yeah, so that certainly would, if you write that down and that shows that you know what's going on, and then you say, oh, log to the 4 equals, log 4 of 1 over 64 is minus 3. I mean, often I think you'll see if you look at the exams that are on LMS, sometimes they might just write, why is log 4 1 over 64 equal to minus 3? Because 4 to the minus 3 equals 1 over 64.
Yeah.
So, in a sense, this statement and this statement are exactly the same. Yeah. And because you know this, you work backwards to that. So usually, I mean, if you write that down and then said that, or a bit more succinctly, you said because 4 to the minus 3 equals 1 over 64, you've got that, then that'd be fine as well.
Cool. And you could do that with any number. You could do like 2 to the negative 2 or 3 to the negative 2 or 5.
Exactly.
Yeah, and it would just be to the 1 over whatever, 3 to the power of 2 or 5 to the power of 2. Yeah.
The trickier one would be something like, if you were asked log base 4 of, let's say, 32 is what?
So 4 to the what equals?
Yes. So 4 to the what equals 32.
32.
4 to the what equals 32. Now, this is a little bit trickier because when you look at your powers of 4, okay, 1 times 4 is 4, times 4 is 16, times 4 is... and 32 fits in here somewhere.
Could you break up the 4? Like, could it be 4...
Yes, that's exactly...
4 squared in brackets, and then to the something?
To the something, that's right. So basically what you would do here is, and it is a little bit trickier. So you know that your log is going to be somewhere between 2 and 3.
Yeah.
So what you do is you think to yourself, well, 32 I can write as a power of 2. So that's 2 to the 5.
Yeah.
Now, why does that help you? Well, because 2, okay, so 2 is actually 4 to the half.
Ah.
Okay.
Which is 5 over 2. 4
And
to
then,
the 5 over 2.
Which is 4 to the 5 over 2.
Yeah.
That's exactly right. And now, because 4 to the 5 over 2 equals 32.
That's our missing power.
That's our missing power.
Oh, that's awesome.
It's pretty neat.
Yeah.
But it requires a bit of lateral thinking because you've got to kind of have two things in mind that, 32 is a power of 2, but 2 is a fractional power of 4.
Yeah.
And if you do that step, and it is, keeping two things in your mind at once.
Yeah.
And of course, what's 5 halves? 5 halves is 2.5. So 2.5 sits up there.
Yeah.
There's 5 on 2. So 2, 2.5, 3, and the 4 to the power of 2.5 gives you the 32.
So I guess as a mathematician, it's good to sort of know all the relations numbers have to each other, like 2's relationship to 4,
Yes.
and to the powers of whatever, or to 8, or yeah.
Yeah, that's right. So, I mean, mathematics, in a sense, is all about relationships all over. So, when we're doing research, you've just got in mind all these other things, and you don't know everything, but you see after a while how certain things link to each other. You're working on something, and you'd say, "Oh, if only I could get." I know 32 is a power of 2, but how does I need a power of 4? And then, okay, but 2 is a power of 4, but it's just a fractional one. It's just when you've got all these tools at your disposal, then you can build it up.
Yeah. Sounds like those scientific algorithms that people work on, and they have all these like base tools that they use, and then they get to string theory and all these crazy, really interesting theories. Yeah. Similar with maths, I guess. I guess they say maths is the purest form of science, don't they?
In a sense, it is, because it's. At one level, while in a sense it starts out. You've got one thing. Let's see, one thing, and then you add another thing, so you've got two things, and you can go from there. But sort of after a while, it becomes its own little universe of abstraction and logic. It just happens to be able to describe things out there. So there are some people like me who believes that mathematics is just out there. Other people believe that it's a construction of the human mind.
Then we get into philosophy.
Then it gets into philosophy. But certainly, from that point of view, that it's certainly true that mathematics is, once you get beyond a certain point, it really is very abstract. I mean, it's abstract and it's logic, and from that point of view, it's sort of more pure than physics or chemistry, which are dealing with physical things.
Like I remember imaginary numbers from high school. That was years ago, and that would go into this very not near the practical at all. Just completely theoretical. In the clouds is what our maths teacher would say. You've gone.
That's true in one sense, but when I teach complex imaginary numbers, I think I actually said this in this class. Every time you turn on the light switch, to put light on in your room at night, or you want to boil the kettle, or you want to turn on the television or the computer, or whatever. You're actually using complex numbers, imaginary numbers there, because the mathematics of the way electricity works and gets pushed through the wires, the transmission lines, revolves around imaginary numbers. It's really quite amazing. I mean, you wouldn't think of it, but without that mathematical analysis, using imaginary complex numbers, you couldn't do the mathematics of power transmission, electricity transmission.
Yeah, and the universe has to follow these rules, otherwise things wouldn't work. Yeah.
That's exactly right. Yeah. Okay.
Cool. Thank you.
Look,
Half past. Yeah.
Time to go to the next thing. So, any last minute questions?
No, it's really good. Thank you.
Oh, no worries. Okay, so I'll see you all on Monday, I guess.
Good. Thank you.
Okay. Cheers. See you later.